The energy sector faces complex challenges. Wind power production, by its nature, is unpredictable, and electricity market prices fluctuate constantly. This volatility directly impacts the profitability of wind farms. The wind doesn't ask when it's best to produce, but the market does. This phrase captures the essence of the problem. Generation doesn't always coincide with the moments of greatest economic value. The strategic solution emerges in the hybridization of wind farms with battery energy storage systems, or BS. This integration transforms the operation from a mere generator to an intelligent energy manager. The key question that arises is fundamental to optimization. When is it best to deliver energy to the grid, and when is it more strategic to store it for later sale? The answer to this question defines economic success. A visual analysis of actual wind generation versus market prices reveals significant opportunities. The ability to decouple production from the moment of sale is a paradigm shift. The integration of BS redefines the primary objective of a wind farm. Previously, the goal was to maximize energy production. Now, the focus shifts to maximizing the value of the energy delivered. This new perspective introduces additional and more complex temporal decisions. The system must decide whether to store energy, deliver it immediately to the grid, or even limit production in times of negative prices or oversupply. To operate effectively, the system requires advanced capabilities. It is crucial to accurately anticipate market prices and coordinate turbine and battery decisions in real time. The impact of these intelligent decisions is profound. Optimized management can significantly increase revenue, transforming project profitability. A wrong decision can mean losses. A smart decision can triple revenue in certain periods. Multi-agent architecture is fundamental to managing hybrid wind storage systems. These agents collaborate to optimize energy value. Agent 9, the hybrid energy coordinator, assumes a central role as the primary decision-maker. Its functions include determining the flow of energy to the grid, storage, or retention. It receives crucial data from the market agent, the weather forecast agent, and the BMS. Sub-Agent 9.1, the BS charge-discharge optimizer, evaluates complex criteria. It considers the battery state of charge, expected degradation, market spot prices, and forecasts of future wind generation. Sub-Agent 9.2, the instant profitability evaluator, performs a key analysis. It determines whether it is more profitable to store the energy and wait or sell it immediately, managing the associated risks. The system's focus goes beyond mere wind production. The system no longer just thinks about wind, it thinks about revenue strategy. Let's consider a practical scenario to illustrate the hybrid system's decision-making. At 12.0, the wind is stable, with a production of 24 MW, but the spot price is low, at EUR 27 MWh. The forecast for 5 p.m. indicates a significant change. Wind power is expected to drop to 15 MW, and the price to rise to EUR on 12 MWh. This volatility presents a clear arbitrage opportunity. Given this forecast, the hybrid agent makes an intelligent decision. It orders the batteries to charge between 12 p.m. and 3:30 p.m., reaching an 85% state of charge. At 5 p.m., the system injects energy in an optimized manner. 9 MW are discharged from the BS, complementing the 15 MW generated by the turbines. The result is revenue maximization through smart and strategic production. This isn't about producing more, but about producing smart. Hybridizing wind energy with storage offers quantifiable and strategic benefits. One of the most notable is the increase in the value of delivered energy. Revenue optimization can range from 8% to 14% annually in highly volatile markets. This is achieved by selling energy at peak price times. Another crucial benefit is the reduction of deviation penalties. The BESS acts as a compensator for wind power variations, mitigating uncertainty. Pilot projects have demonstrated a reduction of up to 55% in these penalties. The farm's operational flexibility is substantially improved. It enables participation in ancillary services markets and enhances the farm's reputation with the system operator. The system also manages the intelligent use of the BESS's lifespan. Agents consider battery degradation, optimizing charge and discharge cycles. The system learns profitability windows throughout the year, extending the asset's lifespan. The fundamental principle is intelligent battery management. Hybridization is not just about connecting a battery, it's about giving that battery intelligence. Coordinated decision-making in a hybrid system depends on accurate and efficient information flows between agents. These interactions are the key to success. The orchestrator agent, 1, maintains constant communication with the hybrid agent, 9, exercising overall control and strategic coordination. The prediction agent, 3, feeds subagent 9.1, BESS, with generation forecasts and load planning. The market agent, 1.2, informs subagent 9.2, profitability, about prices, enabling analysis and revenue optimization. The cybersecurity agent, 5.3, monitors communications with the BMS, ensuring system security. The explainability agent, a 7, justifies charging and discharging decisions, bringing transparency to the process. This justification is vital for system trust and auditability. At the heart of all this coordination is the central question: where and when is this energy worth the most? The entire system works to answer it every second. Hybridization with storage is a natural and unavoidable evolution for the modern wind farm. It is not simply a matter of adding batteries. It is about coordinating, deciding, and acting intelligently. The key to success lies in coordination, decision-making, and intelligent action. This is made possible by a robust and well-designed multi-agent system. The economic impact is undeniable. Comparing revenue curves with and without BESS optimization demonstrates a significant increase in profitability. The final message is clear and compelling. When the wind blows, the system thinks. Operational intelligence surpasses simple energy accumulation. Accumulating energy is not enough. Equipping it with multi-agent intelligence is what maximizes its value.